Okay, we're going to watch a short video. We're going to talk about anchoring. Okay. So when does the ship actually anchor? Why do we need anchoring? Is he going to come back? He's going to start recording. He started recording already. Okay, that's great. All right. So when would a ship be anchoring?
Waiting for berth.
Waiting for berth. Very good.
Looking at the avoid the movement between drifting. Stop the vessel in the middle of the sea.
Yep. Ship is not like your car. You cannot take it to a parking lot and park it and leave it. That is not going to go anywhere by putting a handbrake. Yeah, it will drift. Wind, current. You saw it yesterday?
Yes.
Out there, right in the open sea, when there are no dangers around, well, don't need to anchor. You can keep drifting whichever way you like. It's not going to make much of a difference. But anchoring would be a merchant vessel's way of going and parking itself, something like in a parking lot. Make sense to you? But it is not a very simple way of doing it, where you go and you buy a parking ticket and you position your car and you leave it there. Your vessel is going to be subjected to uncontrollable factors. Uncontrollable factors are basically your weather, wind and current. Yeah, that will play the effect on your ship when your controllable factors like steering and propulsion are lying dormant. That is your idea. When you go in a parking lot, do you leave your car running? Doesn't make sense. You will burn fuel. Make sense? So when you again go and park your vessel or anchor, you will switch off your engine. Yeah, propulsion system will be on just standby. It will be off. It will not be running, and your steering system will be just standing by as well. You're not going to be doing any steering at that moment. But you want your ship to fight against the uncontrollable factors, or you should be able to control the uncontrollable factors still by using something, and that thing is your vessel's anchoring equipment. Well, every ship has two, one on port, one on starboard generally, a conventional merchant vessel. Some have one on stern as well, depending on the nature of operations. Yeah? What is the nature of the operation? So, we are going to be practicing general merchant vessels. We are going to be talking about general merchant vessels. What is it so simple to just go and drop an anchor? No. You will have to approach slowly. Yes. Stop your vessel and then drop the anchor. And then you'll have to also decide upon how much cable to pay out. What holds the vessel in place? The anchor? No.
The weight of the chain.
The length of the chain that you lay on the seabed. Yes? That creates friction. Yeah? And then that lays your vessel at rest. And the anchor is basically the hook at the end of that chain that keeps the chain in position. Okay? The weight of the chain, the length of the chain, the cable that you lay on the floor will hold your vessel. Well, then each ship would be designed with the type of anchor it needs and the length of the chain that is there. It is all required. All this is designed on basis of the classification society, based on what is safe and what is efficient for the ship. Yes. Generally, you will find conventional merchant vessels with an average, you can say, an anchor chain length of about 10 to 11 shackles. The classification society states a total length of the chain to be present on the ship, but then you divide it between your port and your bow. One or the other will, of course, have generally more than one. The port might have 10, the starboard might have 11, starboard might have 12, the port might have 30. Depends how they have designed it. Okay. What is an anchor? General diagram of an anchor. If you see, it has a stock. Always struggling to find a pen. Yes. Other is that only one or two are left now. Okay. We are not going to get too much detail into the construction of an anchor. Yeah. So these are the flukes of the anchor. They move about forward and up to a certain degree of motion. Yeah. This is the what is this?
Anchor arm.
Anchor arm. So you've been at sea.
I forgot to
Try to find out when you go home today. This is basic stuff. Yeah, there's no point covering this. Try to read the parts of the anchor today when you go home. Yeah. Try to put in some effort. Well then, this is a joining shackle, and then there goes the chain. Yes. Now, how do you measure the length of the cable? It is measured in shackles. Yeah. And one shackle is 27.5 meters. And there are markings on the chains to somewhat know how much has been paid out. Okay. So the anchoring operation, it is not just the anchoring operation, it is first you have to understand the anchoring equipment as well. So you have an anchor, you have a chain. Yes? The size or the weight of the anchor and the length of the chain is decided by the classification society. Each vessel, what are the needs and stability of the equipment that you need. You do not definitely need what a VLCC will need. A tugboat would not need that. Make sense? Same is with anchor, and the chain should be compatible with the anchor itself. The chain should not break when you let go the anchor. It should be able to support the anchor and should be go of good enough strength so when it's laid on the floor can hold the vessel as well. So it's all a combination of everything. General design, a ship will have a chain locker where all this chain will be piled. Yes, and this will be coming out through a okay, and then there will be a gypsy, or you will say anchoring equipment, which will be then rotated, which will be able to rotate with the help of a hydraulic motor. Yes, and there is going to be a hose pipe. Yes, this is the hose pipe, and this is the spurling pipe. Okay, two pipes, one to let go the chain, one to put the chain back into the chain locker. Yes, and this is going to be your anchor here, is stored here inside. Is the anchor housing basically. The anchor is housed inside here in this position here so that it is safe and it is nicely tight and housed. It is not loosely hanging about so that if it is out there at open sea, it can then go and puncture the ship's hull. So it is nice and tight placed in this housing over here. Well, of course, people go forward. You are anchor wherever you want to pay out the anchor. What are the factors that you will decide when you are going to pay out the anchor? Depth, very good.
current and wind.
Current and wind, okay. Direction, okay. Keep talking. Think, I want you to think. Because if you are not going to think, you are not going to anchor. You will end up anchoring in an unsafe way. Come on, think the more.
The radius of turning radius.
Turning radius, very good.
And then ship length of the ship.
Length of the ship, okay, very good.
The ship is meters
The available room, okay.
Anchorage area.
Anchorage area, okay. Come on, there is more to that.
Which channel contact the show zero?
Which channel to contact the show people?
Okay, here.
For
Usually Anchorage area. Very cool.
Come on, think harder. Okay, let's have a look. Direction and strength of the wind and current that we have talked about. Depth of water, somebody mentioned. A type of seabed. Yes.
Yes.
Why type of seabed? Well, that will decide how good the anchor is going to hold.
Yes.
The anchor holding will be also directly be, you can say, is going to be depending on the nature that of seabed that it is hooking onto.
Rock.
Yeah, mud, sand, gravel, rock. Of course, rock is not going to be a very good holding ground, is it? It's just going to slide. Gravel, is it going to be really good? Not so much. Then comes sand, not really good. Sand and mud mixture, somewhat okay. Mud, clayey mud, perfect. Yeah, but then what are the problems with clayey mud? If you anchor there for too long, your anchor, it might get embedded into it, get stuck into it, or you can get lots and lots of mud coming with the anchor chain. Huge problem. Yeah. So everything has its pros and cons, but the best anchor holding capacity is going to be with the mud. Yeah. So it is very important when you go and drop your anchor. Now when you go and drop your anchor, you better make sure that you end up not going and dropping your anchor on cables and pipelines, submarine cables, submarine pipelines. Yes. Big problem. It can lead you into a big problem. You can be fined, hefty fines, damages. Your anchor can itself get stuck because when you pick your anchor up, you will uproot all the pipelines.
Is there a special fine?
They will be mentioned on the charts. There are navigation warnings to that effect. So if you have not corrected your maps, your charts that you are using for anchoring are not up to date, well, then you can land up into a lot of trouble. It is preferable to anchor inside the designated anchorages areas. Those are generally kept neat and clean. Well then, sometimes you need to anchor outside the anchorage area. The problems with anchoring within anchorage areas are also not plenty. People dump a lot of stuff. When a ship is in an anchorage area for a long time, people dump wires. People let loose their anchors. Yeah. There is a lot of stuff lying around in an anchorage area itself sometimes, like loose anchor chains, stockless anchors, or anchors which have broken or damaged or left behind your ship. Anchor might let go and drop on top of another big broken anchor, basically landing your anchor on a rock, breaking it, picking up wires or fouling your anchor. There is another problem. So you are all aware of all of that. Location of the lee shore. Look, hazards such as submarine cables and other obstacles we have already talked about. Now location, how far are you away from dangers? Because you have to keep into mind that your anchor might drag because of wind and weather and n number of factors that are outside your control, uncontrollable factors. So do you have a safety margin in the time where you can get your engines and steering ready and pick up your anchor and move away from there? Do you have enough time? Yes. Maneuvering room for approach. Can you actually approach that anchorage? Is it even approachable? Is it feasible to do it? The orientation that I'm going to go and enter. Yes. Swinging room after anchoring. Your ship is going to swing around. Yes. It's not going to go and stop there. It's going to swing around. Once it stabilizes, the effects of wind and current will take over. So is my ship going to swing around safe enough? Next thing you know, you go and anchor next to a ship which is already anchored, and then you swing and go and hit him. Yeah. Conditions affecting visibility, weather, and current. So you should be able to able to forecast, predict, or know what is the current weather conditions. You should be, when you are approaching in the anchor itself, you should be able to make out once my anchor is steady, which way am I going to swing, how am I going to vessel get oriented. All of that you have to play. Depends. Going to face heavy weather, huge winds, currents, so you can use two. Holding power is increased. A mooring of kind of an anchor in an open moor, which then limits your vessel's swaying movements. Your vessel is not going to move around so much. It's almost like mooring. So it's called mooring. And then depends on how you want to keep the angle of the mooring, preferably 45 degrees, 60 degrees. To hold your vessel in a position. Okay. Moving on from this one. This is very important. You should take a note of this. How much chain are you going to pay out? That is one big question. How much chain are you going to pay out? Well, the length of the chain that you are going to pay out, there are Japanese standards, UK standards. The length of the chain you can say is basically 1.5 times square root of the depth of the water. That is the number of shackles that you are going to pay out. Number of shackles that you are going to pay out.
Plus 90 here or
1.5 times square root of h. That is your number of shackles that you are going to pay out. Well, then the Japanese have their own methods of calculation. There is not one fixed specific formula. So it is normal anchoring, heavy weather anchoring, length of the chain. They talk about length of the chain rather than shackles. So I want you to take a note of this. So very quickly, can everybody tell me, if you go and anchor in a depth of around 20 meters, can you please tell me how much shackles you are going to pay out? A depth of 20 meters, if you are going to anchor your vessel and the water depth there is 20 meters, how much shackles are you going to use? How many shackles of anchor cable are you going to use? 6.7. So you are going to use 6.7. You will tell the ship to at least pay out 6.7 shackles. We'll try to keep, see, in shipping industry we work on some rules. That's one good thing about on a ship. Things are simple. Either it is 6 or either it is 7. And what would be more advisable? Pay out 8. One, to keep you more safe. That is one way of the approach of safety. Yeah, that's what we take on tankers. You are going to be working, if somebody works on a tanker, what they do is they try to be extra safe. What is the research that has gone behind this? Well, we are not going to get into that detail. We are not doing a research and development project on how much cable to pay out in a in a laboratory or in with some computers. Somebody has done some research already based on all this. What we are going to do is we are going to create another rule, safety rule. Put one shackle extra if you have. Based on your sea room, you see there is enough swinging circle around. The more cable you will pay out, your swinging circle is going to get bigger. You have to bear that in mind. Okay? What is another important thing that you are going to bear in mind when you are going to use your anchoring equipment? Swinging circle you have already checked. Nobody talked about the duration or the length of the stay of the vessel. How long are you going to stay there? Is that important? Yeah. So if you are going to be anchoring in a congested anchorage, so if this was your anchorage, yeah, and let's say this was the shoreline starts from here, yeah, and there are n number of ships in this anchorage, and you are coming from the seaside into this anchorage area. Where would you want to position yourself if you are going to stay here for 2 months? Yeah. In the middle? Well, I would prefer somewhere over here, right behind. I don't want ships going past me again and again. If I'm just coming here for 1 day, where would you want to anchor? Here?
No, near the
Just somewhere here or here, somewhere in this zone. Make sense?
Yeah.
That is another common sense. Yeah. Come here for one day and go and anchor here. Not very productive, is it?
Yeah.
Also the method that you are going to use to anchor. Yeah. There are different ways. If you are on a smaller ship, bunker barges, smaller tankers with a less, not so heavy, conventional anchor. So what happens is, if this is your ship and this is your seabed, when you drop your anchor, there are two ways of dropping your anchor. One is boom, let go with the effect of gravity. It just comes and goes and hits. So when an anchor is going to come and drop from a good, decent height, and it's going to travel, let's say, a distance of, let's say, water depth we just calculated about 20 meters. Yeah. And let's say your freeboard is at another 10 meters. So it's going to take a fall of 30 meters. 30 meters of fall is effectively, that's the floor that you are sitting on roughly. Yeah. So if you drop a big and a normal small anchor or a weaker anchor, or we cannot say that something that is very heavy, at least 1 ton. VLCC has about 16 to 20 ton anchor. Yeah. Very big, almost the size of this, half the size of this room will be the flukes. The flukes are from here all the way. So if you drop, and especially on big LNG and LPG vessels, anchor will be somewhere around 10 to 10 tons at least. So if I drop a 10 ton anchor from here right to the bottom, is it a good idea?
No.
Not a good idea. So you want to do it in a controlled way. So instead of let go, you are not going to let go. You are going to walk back. Yes? What is walk back? You are going to use your ship's anchoring equipment. Yes? In a controlled way to slowly walk back the anchor. You are going to use the same speed of paying out the anchor the way you pick up.
Okay.
You understand what I'm saying? So you are going to use this, your windlass. It is called the windlass. The anchoring equipment. Yeah? So the windlass, you are going to use your windlass and put it in a gear and use your ship's motors to pay out this anchor slowly. So what a ship does is, before it reaches the anchor position here, let's say this was the planned anchor position on the chart. Before it reaches here, it walks back the anchor to the water level.
Yeah.
So that you save time. And then once you are at the position, you start walking back and then paying out until you hit the right number of. While you are doing that, what is of concern here?
Position of the chain.
Position of the chain. Also, what is of importance here is your ship's bodily movement in respect to the ground should not be faster than your paying out capacity. Otherwise, what will happen? Load will start coming onto your windlass. Is your windlass designed to take the load of your ship's whole weight? No. It is only designed to take the load of the anchor chain. But the motors that are associated and the gears that are associated with the anchor handling equipment, they are supposed to take the weight of they are designed to take the weight of the anchor chain and to some duration, to some extent of the load. But if you start putting the whole load of the ship onto the chain, that is not a very good idea or a right idea. Yes? Accidents have happened in the past. People have uprooted machineries. People have broken anchor chains. People have done lots of stuff. So it is very advisable to monitor your speed over ground. What is your speed in respect to the ground? Not your speed over water. Speed through water is not, nobody is concerned with speed through water here. If a current is flowing in this direction of 2 knots and your ship is stopped, what is going to be the speed over ground? Zero. And your speed through water will be 2 knots. Make sense? You should be able to appreciate this fact. Okay? So that is what it is, basically. Then you also need keep an eye while you are doing the anchoring operation of the orientation of the chain. If this is the ship, and if this is the orientation of the chain up and down, it is That means not much strain is coming. It is just nicely going down. It might also be, there might be a possibility of everything piling on top of each other here, which is also not required, or which is not not advisable, or rather of use. So best is you come to an anchor position and you slowly start falling back. Yes. Then you lay the chain nicely onto the floor. Your anchor. Yes. That is the idea. This is up and down. This is short stay, and this is long stay. Do you want long stays? No. This small angle is how your chain is expected to lead at the floor. That is short stay. If long stay happens, what happens? Too much strain is coming. It's under load now. Pulling. You might either drag the anchor now next to it. So this is not a. This condition is not advised or of use any use to us. It is better to stay in this situation. Right? So there is a term called vessel brought up. Yeah, a lot of confusion is talked about it.
What happens if you make a pile of like once
Once you make a pile, well then things can get entangled, or it is you are not laying your brought up time is going to be taking a long time. It is better is that you come, you drop your anchor, and you start falling back. Yes, with a decent speed. Now I will talk about the speed. The anchor paying out speed is, for general ships it should not be 0.3 knots, which is basically the turning speed. So it will pick up 27.5, that is your one shackle, in about 3 minutes. That is your paying out speed. Generally, round about that. You can convert that. It will come about to be 0.3 knots. So your vessel speed over ground generally should not be more than 0.3 or half a knot. Generally. So you will have to go on each kind of a vessel and see what is my design capability. If you are on a smaller ship, you can then just let go the anchor. There is not much of a problem with let going anchor if there is a very smaller anchor. Yes? Bigger ship, these are the problems. What you can also do is, you can walk back the anchor and you can know how much shackles my vessel anchor is going to touch the bottom. After you pay out the initial 2 shackles or 1 shackle, or your anchor is, you are 100% sure now my anchor is at the bottom, then you can quickly pay out the other shackles if you are in a hurry. Yeah, you can pay out, break, pay out, break. Okay, to pay out the anchor very quickly, then the only way to do it is you disengage the clutch that turns the windlass. You disengage it and you control it by the brake that is holding the wheel, that allows the chain to pass out. You will see it in the videos now. I will show that to you. It's all up to you. Does this make sense? Yeah. Yes. So, what is the best way to anchor is, so that you don't get into much troubles and problems, is if the current was in this direction, yes, it was coming like this. Let's say the current was coming like this. Yeah, it's better to head into the current. Head into the current. If this was your point that you would have planned to drop, head into this. Now, another thing that you need to know is, this is your ship's bow, and your position of your antenna that is coming from the GPS, the satellite, is based on here, and there is another length of your ship all the way about 200 or whatever meters from the bridge to forward. You can see it in your plans. That is where your anchor is. Sometimes in tighter positions you need to keep this in account. That if your electronic position system is telling you that you are here on the chart, that does not mean that you are going to drop anchor here. What that means is, if this was your required position to drop anchor and this was the ship, when your bridge is in this position, that is when it will show you on the chart that you are here. But then you actually passed ahead of your anchor position. This is where your anchor lies. So sometimes you have to, if you are working on bigger, longer ships in tighter positions, you will have to bear into mind that so much distance away from this position, what I am getting through my satellite systems, I have to drop my anchor. That is the point where you will be actually dropping your anchor. So if you are going to be entering a congested anchoring zone, and there was already one vessel anchored here with a swinging circle, most common sense like this, and you are going to drop anchor here. So what you are going to make sure is you will take your ship bow to this point, not your ship bridge where you generally sit. Yeah, and then start paying on it.
When the ship is like swinging it, the thing like that is that much of anchor is on the seabed, and
Generally your ship will see it in the video as well. Let's say here you paid out 100 meters of cable. Yeah.
all 100 of meters cable is not also swinging as well.
Depends on the depth. You can roughly say about if 100 meter was here, what is going to be the depth of the sea water? Let's say this was 20 meters. Yeah. Do you think this is going to be 20 meters?
More than
No, definitely more. How much more?
that.
You can do a small calculation. How much is this angle? Roughly about 30 degrees. So can you calculate this using trigonometry? Say about 30 meters. Then 70 is on the floor. Yeah. So you can calculate this distance as well. How much is this distance going to be? Let's say about 10 meters. So you have 70 on the floor, 10 distance, and then plus the length of your ship all the way to the bridge to the stern. Yes? Then your ship is going to be anchored around here. So worst case scenario, you will consider your spinning circle all the way from the point you have dropped your anchor, and you calculate all that distance.
Okay, my question was like also that, for example, we see 70 meter of chain on the seabed. Also, all this 70 meter will also like make a circle as well. It will turn on.
See, there is no 1% one correct answer for this. Sometimes when you lay the chain on the seabed, the chain is going to be twisted, turned. You are not doing a 100% ideal anchoring operation all the time. Yes, you are assuming that your chain has been laid out correct. What is the best way to lay the chain out? If the chain is laid out, is it going to be laid out in a straight line like this? No, it might be. And is your seabed going to be one flat plane like this? No. Your seabed, it might be something like this. Possible? Yeah? Yeah. Depend on the terrain of the seabed. So if you go and start anchoring somewhere on this kind of a terrain, so you might drop your anchor here, and your chain might just start going out like this. So if you look from the bird's eye view, your anchor might be just what, like chain might be laid out in this position. Generally, when you try to anchor, what you try to find is an area of same sounding. Yeah? If the sounding on your map, the map that you use, sounding is 10 meter here, this is a 10 meter contour, yes? And this is a 20 meter contour. And suddenly in between, there is a 50 meter contour here. What does this mean? This means that there is a big hole here. Because the map that you use, you are not using 3D maps. Are you? So you have to pay attention to the map. Let me show you the map. You see the map here? This is somewhat a normal plane. This is 10 meters, 14 meters getting deeper, 13 meters, again 10 meters, getting more shallower. So it is not a simple plane, is it?
No.
Pay attention to this. See the seafloor here, 95 meters, 40 meters. Yeah, so it's like going up a hill. Would you want to anchor here somewhere in between? How is your chain going to be laid? Yeah, you are actually, this is how the seabed is going to be like. So you want to drop your anchor here, anchor will be like this. So you have to pay more attention to the chart as well, the map as well. that you use. So it gets more and more complex now. Yeah, not one simple easy operation. So wherever you anchor, you better check the area. What is it? Are there some problems there? Wrecks there? Shoals there? Cables, pipelines? How is the seabed? Nature of the seabed? The topography of the seabed. And just for the safety purpose, after you have chosen everything, and let's say this is the seabed, generally it is going to be like this. Yeah? It's not going to be one flat football field. So you are going to take into account that number of shackles that you have paid. Let's say 10 shackles, which makes 275 meters. Length of your ship, 275 meters. Let's add this. What is this? Come on, my mathematics is not that great. Tell me.
550.
Yeah, good. That's why you're doing PhD and I'm not. Okay, so 550 meters. So let's say if you saw it yourself on the map, and this is where you drop your anchor. 550 meters is how much? If 1 nautical mile is 1852 meters. How much is 550? 550 divided by 1852. How much is it?
Almost.
Come on. Quickly.
They're not vertical enough, but it's like make it.
No. At least something more accurate than that.
0.2129.
0.3
almost.
0.13, yeah?
0.329. No, 0.29.
That's 0.3.
Yeah.
So it's 3 cables. So what you are going to do is from here, 0.3 nautical miles, you are going to draw a circle. And you're going to make sure that that much area is available to you wherever you go and anchor.
Yeah.
Make sense?
Yeah.
So the very science that you use depends on the vessel.
Length of the vessel and the length of the cable that you plan to pay out. Keep things simple. Okay? That is more generic. There is another formula to it, tighter formula to it. There is no point getting into all of that. Yeah? Because again, there's a formula for everything. But we don't generally go and sit on the ship and do all these calculations. We try to keep things safe, keep some safety room. So if you are having a more safety room, wider room you are keeping, then you will keep yourself safe. Yeah? Okay. Wait. Okay. Now, generally, the kind of anchors that are used is AC-14, that is the Admiralty Class 14 anchors, and JIS anchors. Yes, the better and the best is the high holding power Admiralty Class 14 anchors. Yes, the one in the middle. Some ships use JIS anchors, and there are Danforth anchors, and there are some other kind of. Some they have stock anchors and stockless anchors. What you need to pay attention to is AC-14 anchor will hold more than 10 times its own weight if the seabed is good. Yes. And JIS anchors have half the capacity, holding capacity of the AC14 type anchor. Can you see that?
Because of the shape.
So because of the design, you can see that. That is and the following is the pulling distance, holding resistance, XY axis comparison. Okay. Now this is what you were concerned in. The holding part, the length, the catenary part, and the water depth. This is what you were concerned with, right? These are all the formulas that you can use to calculate all of this. What is going to be the holding power of your anchor? Yes, which we are not going to get into the details of it. We are more interested into the anchoring operation. You got the formula already? How much shackles do you need? Yes. What is to be avoided is anchoring in rocks, cables, submarine cables, pipelines. So let's watch a short video. Why is there no volume to this?
Yeah, good idea.
This was
How to prevent drifting due to dragging anchor while lying on a tube.
What happened?
to make it a better part.
Yes.
We don't know how to fix the sound of electric something like and the book this and they from the ground to the segment part. So they put this going through the land. It's really fun. I will show you a video.
Oh, no.
Recently, accidents that have resulted in losses of anchors together with the entire length of anchor cables have been increasing while ships were attempting to anchor. Accidents involving ships lying at anchor have...
No, this incident, this is the bulk carrier of Kashima, and now you're laughing. Everybody died on the ship except 4 people.
What's wrong?
Died? Yeah.
Why?
Because they anchored in the wrong place. They did not pick up their anchor when the weather got really bad. There was rough weather. The anchor dragged and dragged and dragged, and then the vessel went and sat on top of a shoal or something, and it broke into two, and everybody died.
But if they have stayed in the bridge, they will survive.
Yeah, I think accommodation in
This
general.
is later on when the vessel got drifted This is after the weather got okay, photographed. In the rough weather, the vessel turned and twisted, and so it might look very funny to you at the moment. This is later on after the weather became okay, it got twisted. So people have lost their lives there. People will die at anchor station in the forward sea if your ship starts moving way faster and way slower than what you're supposed to do, like the design speed of the windlet I told you. Yeah. And you let go the anchor in a depth of 100 meters without deciding that, okay, this is a very big and a heavy anchor and my vessel breaking. I might not be able to stop the chain once it starts going out. And once the end of the chain starts coming out, of course, there is a bitter end to hold it in place. When ships get old and it comes out, flinging out, knocks everybody dead forward. Okay?
Also repeatedly occurred. Most of these accidents involve drifting, collision, and stranding caused by dragging anchor. We will study how to prevent drifting due to dragging anchor while lying at anchor, and loss of anchor and its cable while attempting to anchor. When anchoring is anticipated, it is essential for mariners to acquire meticulous knowledge on the anchorage beforehand, and select sheltered, good holding ground with an appropriate depth, depending on the ship's own maneuverability and conditions, taking weather and sea conditions, dangers such as submarine cables, as well as pipes and wrecks in the vicinity into consideration. It is necessary to have a clear plan on how to reduce the ship's speed from the approach to the intended anchorage and how many lengths of cable are to be paid out. A method of riding to a single anchor is the most frequent anchoring method. However, the anchoring method should be decided depending on weather and sea conditions, and necessary preparations are carried out according to the selected method. The specifications of anchor and anchor cable to be stowed are decided by the equipment number of the ship. Each classification society also has its own requirements in compliance with this standard. Today, the AC-14 type anchor appears to be the most widely used, but there are various other types of anchor available. Let's look at the holding property of an anchor. The flukes of this type of anchor do not bite into the seabed as expected, and the anchor is easily overturned when stress is applied. What's more, once overturned, the anchor will never bite into the seabed again. These are the flukes of the AC-14 type. The AC-14 type is the most popular anchor today. It bites into the seabed well and remains stable without overturning when stress is applied.
You see, it did not overturn, yeah?
This curve shows the results of anchor pulling tests. Holding power is the resistance created by the anchor when it is pulled. The maximum resistance is called holding power. In addition to the holding power of the anchor itself, the effect of the cable paid out cannot be neglected. The total mooring power is the sum of the holding power of an anchor and the resistance of cable laid over the bottom. Although the anchoring method varies depending on the depth of an anchorage, lying at a single anchor is most frequent because of its handling simplicity, either when dropping or weighing anchor. In this pattern, the anchor is usually let go under sternway. First, we look at the procedure for lying at a single anchor in an area with depth to 20 meters. It is important for the running out chain to be checked by proper brake handling after the anchor is let go by free-fall releasing the brake. Letting go the anchor and the cable without applying the brake properly increases the danger of loosing the anchor with all of its cable and damage to the windlass. Sternway just after letting go the anchor should be adjusted 0.5 to 1 knot to avoid imposing excessive strain on the cable in large vessels. And the brake should also be screwed up to stop the cable when the required shackles are sent out and have the anchor flip right into the seabed under sternway inertia. Next, let's study anchoring at a deeper anchorage depth of from 20 meters to 50 meters. In a deep area, the possibility of loss of anchor and its cable becomes greater due to excessive running out speed if the anchor is let go by free fall. To avoid this hazard, the anchor is lowered by walking back into the water until it reaches about 5 meters above the bottom. Then the brake is released to let go the anchor, while applying the brake to adjust the running out speed of the cable and carefully maintaining proper sternway. When the depth of an anchorage exceeds 50 meters, the anchor and the whole cable required are laid down onto the seabed by the walkback method. In this case, sternway should be maintained under 0.5 knots once the anchor has touched the bottom, because too large a speed difference between sternway and walkback may cause parting of the anchor cable or damage to the windlass due to excessive strain in large vessels. The limitation of depth for anchoring cannot be decided only from the total amount of anchor shackle, and is limited by the rated capacity of the windlass. Generally, a windlass is provided with a weighing capacity of up to 3 to 4 shackles of cable, or about 82 to 110 meters. In an anchorage where the influence of winds and tide waves are strong, there is a greater danger of dragging anchor due to excessive strain on the cable, otherwise due to the reduction of holding power stemming from a meandering cable caused by the effects of winds and tide waves. Anchoring in wind at a wind speed exceeding 10 meters per second causes ship motions that draw a figure of 8 locus. The maximum tension on the cable during this motion occurs when the ship drops back from its extreme yaw to the position where the fore and aft align the direction of the cable against the wind, or a little offset point. This moment may be deduced from the change of relative direction of the wind on the navigation bridge. The anchor drags when it loses its grip on the bottom and starts sliding over the bottom. For a PCC or an LNG carrier with a large windage area lying at a single anchor, the critical wind speed is 15 meters per second. When the second anchor is dropped, the critical wind speed is 20 meters per second. And even when the ship is lying at two anchors, the critical wind speed is said to be 25 meters per second.
You're observing this, right?
Once an anchor starts to drag, it is difficult to stop. Personnel assigned to anchor watch are required to pay close attention to a sudden change of weather and must report it immediately to the master. They should pay careful attention to weather forecasts. A great advantage of anchoring is that ships can lie at anchor anywhere if sufficient room, sheltered from wind and sea, and provided with appropriate depths and good holding ground. Consequently, anchoring is the most convenient and common ship operation due to its simplicity and mobility. Prevent an accident resulting from dragging anchor, loss of anchor and cable, the personnel who engage in anchoring are required to do their jobs with sufficient knowledge of the anchoring system, including the windlass, as well as the necessary skill.
You can see this is the anchoring equipment. You are seeing the port anchor here and this is starboard anchor, the windlass. Yeah. And person here is controlling it. How now the way the anchor is right now going is they are paying out the anchor. It is going in an uncontrolled way. All they are doing is they will be controlling it with a brake that is holding the wheel that it is passing over. That's the only way to control this chain. But that is not a very advisable situation to do if it gathers too much momentum, because everything can look very good on paper and calculations, but due to weathering of the equipment over a period of time, wear and tear, it will not somewhat be able to prove it itself the way it has been certified or subjected to calculations. Next thing you know, it doesn't stop. So it does not stop. What will happen? It will keep going out until when? Until the end. There is a safety measure for that as well. The end of the link is holding on to the bulkhead in the chain locker. It's called the bitter end. Well, of course, everything is subject to rust and stress, and over a period of time, again, wear and tear. Is that going to hold the final jug that is going to come? Well, it is designed to, but is it going to? Do you want to find that out standing here? What will happen to this gentleman here if that last bit of link comes out flying? Well, then he can get squashed like a bug, and all of this equipment here is going to get extremely damaged and broken. Forces are amazing. And I don't know what you have observed at sea or what you have not, but let me tell you, even a small piece of rope, size of thickness of my finger, if it parts, it will cut you into half, two pieces. And the size of steel wire, not even thicker than my little finger here, even smaller than that. If it parts, it will cut all of us into two pieces. Okay? And look at the size of this chain here. Well, this is what you see from the ship side, the stay of the chain. This is somewhat medium stay. Another bit that we need to see is, just hold on. Be a bit patient.
A ship at anchor will swing around the anchored position in the wind, moving as if to draw a figure 8.
This movement will be a
First,
combined
the
effect
ship
of current
begins
and
to be
wind.
swept away backwards subsequent to its heading on the wind and the extreme end of the windward turning. Then, due to the backward motion of the turning moment on the leeward with the heading nearly unaltered, the cable tension greatly increases due to tension by wind force, and that by inertia force by the ship's accelerated motion. Now let's look at the relation between the wind speed and its force under the swing motion of the ship by wind direction. As shown in the graph, when the wind of 15 meters per second is blowing, the wind force is about 8.4 tons with the relative wind direction of 0 degrees, but the wind force increases to about 52 tons with that of 30 degrees off bow. Thus, it is shown that the wind force acting on the hull grows much greater as the angle of relative wind direction off bow increases. According to on-site reports from masters, when the ship is riding to a single anchor, the maximum angle of relative wind direction in degrees under swing motion is reckoned empirically as approximately double the wind speed in meters per second. The safe measure for preventing dragging anchor is how to control the swing motion of the ship while a full length of cable is paid out for the increase of its holding power. To control the swing motion, a swing check anchor is used with another anchor lowering to some 1.5 depths of water on its cable. This method can reduce the magnitude of swing motion on the order of about 50%.
The tank of the anchor is movable, right?
Say again?
The tank of the anchor is movable.
Yeah.
So if we are returning to another side, it will come to this way.
I understand your question. What are you talking about?
Okay. For example, as we see the vessel is moving in the south. So if it's the wind pushing the vessel to another area, the tank will be adjustable to that area, right?
No, you will only do that in a place where the wind and current is steady, only in one direction.
Okay.
Why will you pay out two anchors if there is wind going to change from back and forth? You're only doing that in a place where your anchor is going to be into a one steady wind and you don't want it to move too much. So you will just move in one.
So I keep that anchor just swinging in the water, not touching the sea surface.
Said 1.5 times the depth. Here's what he said.
One and a half.
Okay, this is the exercise today. The first exercise for anchoring. Please take a note of it. There are two ships here. One is LPG Omega. One is Glasgow 1. Glasgow 1 is your LNG vessel of 89,000 tons, and the LPG Omega is a 33,000 ton LPG tanker. You have two anchors, port and starboard. You can read about your anchor details in the details that I have provided to you. You are just off the LNG terminal Yung An LNG terminal in Taiwan. There are two ships already here at anchor. The current is, let me see the wind and current conditions. The wind is about 20 knots coming from 090. Yeah?
The wind?
Wind is 20 knots coming from 090, and the current is going to 1802 knots.
So,
Yeah? So the current is southerly, current is going to 1802 knots, and the wind is coming from
090.
About 20 knots. Okay? Happy?
180.
And your ship is going to start, the time of starting is 1700. 1700, you are going to start this exercise. Can you see the time here? Right at the bottom. 1700 is your starting time of the exercise. Your telegraph position is going to be full ahead. So two of you who have been to sea will be in one team, and two of you who have been to sea will be in one team. You can accompany them. Yes? If you want, I can load this exercise on bridge 1, and one on bridge 2. Okay. But honestly speaking, this anchoring exercise, if you want, you can yourself realize that later on bridge 1, it is not going to make a difference to us. It's a simple exercise. Two ships are already at anchor. When you go to anchor, it is good to find out what the other ships are heading and see. Why? Because the other ships have been there before you. So how would they be heading? That is something to be thought about, giving you an idea of how your ship is going to settle down after you finish anchoring. Okay. Yes? If you're going into an anchorage, congested anchorage, you would want to see a vessel of somewhat of your type and design that how is that ship heading into an anchor, because after your ship finishes anchoring, it is going to settle down in that position. Okay. Yeah? So can you see this? I will put this on your route in your Excel. You can see it. Your exercise will start in autopilot. Whenever you are comfortable, you can take it on hand steering. And which I think the team on the left, you go on the LMG. Your starting speed is about 11 knots. That is your full ahead position. Can you write this down? And your first leg, the distance that you will be traveling is about 3 miles. Yes? Okay. And the leg that after you go into the anchorage, the last bit of your leg is about 1 mile. 1 mile. Okay. So you know you did did you do these things on the, who did the turning and swinging and the circles on the LNG? Yes. You did it? So you understand your ship to a certain degree. Try to put that to use. On LPG, your first leg is of about 1.5 miles. After that, you make an alteration of course to the next course. You're heading start with a course of 090, and then you head into a 006 degrees course of 007, another 1 mile to go to your anchor position. Okay? I will give you a walkie-talkie. Imagine that somebody is already there in the forward station.
What about the speed for the LPG?
LPG, it's also the same speed.
11?
Doing 10 knots, starting 10 knots, your position is full ahead. So whenever you want, you can reduce your engines are ready to reduce at your own disposal. You know how much time you are going to take to stop. You have done that exercise before. You know somewhat maneuvering. You have your wheelhouse poster with you. Yeah. So let's give it a shot. I will load your exercise. I will come on to your bridges, give you walkie-talkie. Whenever you are ready, I will start the exercise. So people who are on bridge, LNG, your LNG ship's name is Glasgow 1, and the LPG ship's name is LPG Omega. Okay? So if you want to contact me, you will call me as LPG Omega. Yeah?
Glasgow 1.
LNG is Glasgow 1 and LPG is LPG Omega.
They are only
Is that okay?
Okay. So which bridge do we go through?
If you want, you can go on bridge 1, the LNG, and the LPG can go on bridge 2. LNG can go on bridge 1, and LPG can go on bridge 2.